Alright, so recently I came across this AtSaturn video where he made this 90s style anime shader. I wanted to give it a quick shot and see if I can make it or not. And this is the output that I was able to achieve. Evidently not very similar. There is a lot of stuff missing, like this outline shader that he has. I'm not even sure if that is I think that is a shader. I don't know. I wasn't able to make this. It's quite difficult, I guess. Other than that, I think this was pretty satisfactory for me. I'm not a huge shader guy. I don't really like writing shaders all that much. But I did make this, so I just wanted to share how this whole thing is made. This won't be a very step-by-step tutorial if you are expecting that. I don't like making tutorials. I'm not a tutorials guy. This is my 10th time recording this, so I'm already hating it. I'm not even sure if this video is going to be up or not. Okay, so let's see. So the fuck, why am I stuttering so much? By the way, if you still have some background noises in my videos, then I am not going to fix those. I'm not putting any efforts in these videos. I'm just screen recording myself and recording on my mobile. Okay, enough yapping. Let's get back to this. My scene setup is basically a world environment. It's a basic world environment. What's different is my tone map is set to ACES with exposure of 0.5, and I guess you can say there is a glow of 2 intensity and 0.09 bloom. I guess that's different. And other than that, there is a simple camera, just a basic camera, nothing different in it. And in spotlight, in spotlight, the important part is this angle attenuation. Make importantly sure that this value is close to 0. Don't make it exactly 0. Don't be a smartass and make it 0. You will fuck this up. So keep it as close to 0 as you can. Other than that, give it a color, give it some energy, and turn on your shadows. That is it about the light. The setup is same for every light that you add, and there is only one spotlight. This is not 2 spotlights, there is only one spotlight. Other than that, it is just my game objects. These are the same objects used by AtSaturn. I will link the sketchfab in my description. You can find it in his description as well. You will find it in my description as well. And there is a plain floor over here. So we have the matchbox, the cigarette. We also have a cigarette, and we also have a cigarette. Other than that, we have 2 canvas layer with 2 color rect. One of them is for my saturation and contrast. So this is a very, I would say, a standard saturation contrast shader that I use everywhere in every game. So I just slapped it over here as well. And the second one is for vignette, grain, and chromatic aberration. Let's get into the actual shader part. This post P1 is for contrast and saturation, and what the fuck is this? Yeah, this second one is for grain, chromatic aberration, and vignette. So chromatic aberration is simple. You just split your colors and you give the R and B some offset. That's the simplest way to do it. And this is the 2 line of code for grain, I guess, and here's the vignette if you want. I don't know, this is not really the important part. I'm not going to focus too much on this one. Don't quote me on any of this. This is not an explanation. I'm not explaining any of this. It's not important. The actual important script is this base.gd shader. This script needs to be attached on every single game object or every single mesh basically in your scene. This is the shader that is giving this light, the hard edged look, and the tone shader look. So let me get into this script. So the shader type is set to spatial, obviously, because we are making it for spatial objects. In render mode I have disabled specular because I don't want any glossy effect or any reflections. Just ignore this part for now. None of this is important because this is all just me back connecting the variables that are loose by using shader material instead of the spatial material. So you know this terms: texture, albedo color, normal strength, ambient occlusion, roughness, metallic emission. So these are just variables created so I can connect them later on. The important variables over here is shadow threshold and shadow tint. Shadow threshold will basically decide where the light ends and the shadow begins. So in this this bright part is the light and this is the shadow. Yes, this is the shadow. So the shadow threshold will decide where the light ends and where the shadow begins. So if this value is it is set from 0 to 1, if it is set to 1 fully, it will be completely lit, there will be no shadow. And if it is set to 0, then there will just be this shadow, no light. And shadow tint will give this purplish color or any other tint color you want to the shadows. Now in the fragment function, there is nothing to explain. I am just using this uniforms to connect them back to where they belong. There is nothing to explain over here. If you want me to explain, oh, I am using texture normal variable and connecting it to the normal map, go somewhere else. I am not explaining all that. The main important function is the light function. The light function will be ran once by every light affecting the object. So every single point light, directional light, or the spotlight, they will call this function and calculate how the light contributes to the final color. I would say that's the best way to put it. So this will be ran by every single light affecting the object. The first step is to calculate n.l. Now let me explain what n.l is. As I said, I have done this shit like 10 fucking times. I'm tired of it. n.l is basically dot product. This is a dot. It's a dot product between surface normal and light direction. Surface normal is the direction in which the surface is facing. So the 90 degree. A normal means a 90 degree if you don't know yet. And light direction is the direction of the light, which is also a normal vector. And the dot product between these two will give us how much the surface is facing the light. So if the value of n.l is 1, it means we are completely facing the light. If it is something like 0, it means we are not facing the light at all, which means we are not getting the light at all. If this makes sense to you, skip ahead in the video. If it doesn't, stick along, you are about to have a mathematics class. So the formula for n.l is this, and cos theta. Now this is really easy to solve. We can eliminate the n and l right over here. Why? Because n, the surface normal, it's in the name, it's a normal vector. Normal vector are considered 1. And the light direction is also a normal vector, so that is also 1, and then we have to multiply that by cos theta. So at the end we are just left with cos theta. Wow, insane fucking writing, fuck me. So in the end we are left with n dot, what the crash. I'm not even fixing this, fuck this. So in the end we are left with the dot product of surface normal and light direction is cos theta. Now if it still didn't make sense to you, let me explain it a bit more. And I fucked up. Why did I paste the screen recording over here? I want this. Let's say the structure of scene is something like this. This is the surface facing directly up. This is the direction of light coming directly down. So the angle between them is 0, which means we need to calculate cos 0. Cos of 0 is 1. Hence we are completely facing the light, evidently by this diagram. And if it is something like, let's say, 90 degrees at the side, so we have to calculate cos 90, which is 0, which means we are not facing the light at all, which means the surface is getting no light, just like you get no pictures. And if it is something like 45 degree or 60 degree, the light changes as per that. Okay, so that is all the that is all the n dot l part. N dot l is basically a quick summary. N dot l is giving us how much the surface is facing the light, and then we are calculating the cell value. Now what is the cell value? This is basically giving us the hard edge over here for the light and shadow. So we are using a step function which creates this kind of hard edge over here. I'm repeating myself like 10 times. And the two parameters that we give is n dot l, which tells us how much of the area is affected by the light. So exactly till over here, till where the shadow ends. From the center, this is where the shadow ends, so this much area is affected by the light. And shadow threshold will tell us where the shadow should start and where the light should end. So a fun thing that I can do is I can just switch this, and the light and shadow will switch as well. So yeah. Okay, so the next step is very simple. We just have to now apply all this shit that we have created to the mesh or whatever it is. So we are using a mix function to create a blend between the shadow tint and the cell colors, the shadow tint and this light. So if a pixel is in the shadows, it will get the shadow tint color. If it is getting lit by a light, then it will get a bright white color, and then we will multiply that with the light color from the scene, so it is respecting this light color that we have assigned in the scene. And at the end we are just applying the diffuse light with attenuation. Attenuation, as I mentioned over here as well, it basically tells us how the light fades with distance. That's the simple explanation of it, and that is it. That is all the shader part you need, and you will get this. To apply it, go to your mesh. In your mesh, in surface material or wherever, create a shader material, not a spatial material. Read this, it is type shader material. Again, it is not a fucking spatial material, it is a shader material. Apply the base shader, go into shader parameter, give your texture, give your normal, ambient occlusion, all that fancy stuff. If you don't have it, just leave it empty. Asking it doesn't make sense. And then give your shadow threshold value and shadow tint, and that is just it. That's very tense. You are done with this. But you have to do this process for every single mesh, or you can just select all the mesh all together and add the shader. If you do wanna add this chromatic aberrations, vignette and contrast saturation shader, all you have to do is add a canvas layer, add a color rect, set the anchor preset to fill, and apply the shader. The post one is for this one is for contrast and saturation, and the second one is for vignette, chromatic aberration and grain. And you can set the values in shader parameters, and that's it. That you're done with that. I don't know if this counts as a tutorial or not. It's not really intended to be a tutorial. Yeah, fuck y'all, bye.